Alright, what we're looking at today is one more step in the process of being able to sketch your own curve, and that's looking at limits at infinity. So this first is telling you with rational functions is where we'll mainly have the issue. All we want to look at when we have a rational function is the degree of the numerator and degree of the denominator. So if I had a function that was like x cubed plus x over x squared minus 2x plus 1, something like this. The degree of the numerator in this one is 3. The highest power is 3. Degree of the bottom is 2. So when the numerator is higher than the denominator, then the top will increase more rapidly than the bottom. That means that I'm going to have a limit of infinity as my x numbers get bigger. So in the next one, if their numerator is less than denominator, something like x over x squared plus 3, the bottom has a bigger degree. Therefore, it will increase more rapidly than the top. Therefore, my limit will be something over a really big number, which is why it will be 0 as your limit. So this will always approach 0. A graph like this would maybe look something like that. Approach 0, but never quite get there. And then the last one, degree of the numerator and denominator are the same. So say it's x squared plus 3 over 2x squared minus 9. What we want to look here, they're both x squared, so they stay the same. So we have to look now at the coefficients. In this case, we have a 1 in front of the top and 2 on the bottom. That means that my limit here, the limit will equal 1/2. So what that would look like, same sort of thing, except that's at 1/2. It's going to approach 1/2. Just like we would do here at 1, this one is only going to approach the number 1/2. So just to quickly look at an example, see if we can find the horizontal asymptotes here and see what we can find out from this. Go ahead and pause the video, see how you can do them. Alright, our first one, we have the same degree, so degree on top is the same as the bottom. That means the limit as x approaches infinity equals the coefficients, 8 over 10, which equals 4 over 5. That means I have a horizontal asymptote at y equals 4 over 5. In this one, degree of the numerator is less than degree of the denominator, so the bottom is going to increase much more rapidly. That means the limit here is going to be 0 because it's much bigger on the bottom than it is on the top. So dividing by a big number means I'm approaching 0. So my horizontal asymptote is y equals 0. And in this one, top is much bigger than the bottom. That means it's going to increase much more rapidly on top than bottom. So the limit here, as x approaches infinity, is infinity. So there is no horizontal asymptote for this problem right here. And there you have it. That's how we find horizontal asymptotes dealing with limits at infinity.